feel the vibe.
To our last section in the SE.1 notes. Systems and modeling. So basically what we can do is we can take systems of equations into a word problems. So what I did with the first couple ones is I broke them down into steps, and then on the last one we're going to put all the steps together at one time. So problem 6 gives us a scenario. A jeweler is commissioned to create a piece of artwork that will weigh 14 ounces and consist of 75% gold. She has on hand two alloys that are 60% and 40% gold, respectively. How much of each should she use? So it says using X for the amount of 60% gold alloy and Y for 80%. Write a linear equation to represent the weight of the artwork. Well, what we know about the weight of the artwork, if I go back to the original problem, is at the end it has to be 14 ounces. So whatever she uses of 60% X and whatever she uses of 80% Y, that has to equal 14. It says using the same variables, write an equation to represent the percentage of gold in the artwork. Well, this is a little bit more complicated. What we have to take into account here is both weight and percent. So at the end, this should be 14 ounces and it should be 75% gold. So at the end, 14 ounces times 0.75, remember we have to convert percents to a decimal. This is the weight of just gold at the end. So 14 times 0.75, there would have to be 10.5 total ounces of pure gold at the end. Now how do we get there? And we'll come back to this 10.5 number. We'll simplify in a second. Well, how we get there is we take this 60%, which is X, so however much X weighs times 0.6 for 60%, plus however much Y weighs times 0.8 for 80% has to equal this 14 times 70%. So if we simplify this, 0.6x plus 0.8y equals 10.5. So it says use a graphing utility to locate the solution for the system of equations written in parts A and B. So remember, in order to graph this, we need y by itself. So in the first equation here at the top, it's probably a quick fix to get y by itself in part A. Subtract x, so y equals 14 minus x. I can graph this in my graphing calculator. Then for the other one, it takes a little bit more work. Subtract 0.6x, so 0.8y equals 10.5 minus 0.6x, but then I do need to divide by 0.8. So I'm going to come back to this graphing portion in just a second. Let me clear that out. I'm going to come back to this. So y would be by itself. 10.5 divided by 0.8 is 13.125. We're not going to round that. Let's just use that whole decimal. 0.6 divided by 0.8 is 0.75x. So y equals 13.125 minus 0.75x. Now if I go take a look at the graph on this, it's going to take a second, but I can't really see the intersection point. So what I want to do is I actually want to make this a little bit. We see it's going to be somewhere over here, but it's not quite tall enough. So I'm going to click the window key and I'm going to zoom out a little bit. Or you can hit the zoom key and you can hit 3 and you can zoom out that way. And so now I see the intersection a little bit better. Make sure that's on the screen. So hit second, trace, go down to intersect. Make sure it's on the first line, then the second line, and then hit enter along to guess. Oops. This stuff should be over here. So I graph those two equations. I find their intersection point on the graphing calculator, and now I have my solution. So x equals x equals 3.5, and y equals 10.5. So those are my two solutions graphically. Finally, D says present your answer found in part C with the context of the problem. So after we find the algebraic solution, we want to make sure we go back and we describe what it is that we're finding. So remember, X was the amount of 60% gold alloy. So the amount in this problem specifically was in ounces. If we go back and we read the original equation, it said in ounces in the original problem. So there are 3.5 ounces of 60% gold alloy that she must use. Y is 10.5. What does Y stand for? Y stands for the 80%. So there's 10.5 ounces of 80% gold alloy. And we could go back and we could check this again. We could go back to our original equation here and put in X that's 3.5 and 10.5, and we'd see that it's 14. We could go back and put it in this equation and see that that would equal 10.5. So in order to make a piece of artwork that weighs 14 ounces and is 75% gold, she has to use 3.5% or 3.5 ounces of the 60% alloy and 10.5 ounces of the 80% alloy. Let's take a look at another problem where it's broken down like that. Problem 7 says, Karen's at-home business makes large decorative candles for all occasions. Her costs include materials at $3.50 per candle and rent and utilities that average $900 per month. If her candles sell for $9.50, how many candles must be sold each month to break even? So it says, write a linear equation, C of X, to represent cost, C, in terms of X candles made. So in here, there's a couple things that come into cost. Her costs are $3.50 per candle. So we don't know how many candles are made, so we're using this as X. 3.5 times X. But that's not the only part for cost. Notice that utilities average, or rent and utilities average $900 per month. So her cost is an additional $900. So let's write an equation R of X to represent the revenue R generated by X candles made. So revenue is the money that's brought in. Remember, revenue is found by taking the number of candles, which is X, multiplied by what they sell for, which is 9.5. So 9.5X. There's no other way that she makes money, and so this would be the only part that we would be looking for. Now, this is our system of equations. Now, remember that C of X and R of X basically just stand for Y. So we can basically look at this as just a Y, and this is just a Y. So in this equation, we don't have to do any work to graphically rewrite these. So what we can do is we can just go to our graphing calculator and type in these two equations. So let me clear out what's in there previously. 3.5x plus 900 and 9.5x. Let me clear out everything else. Sorry, let's put that in 9.5x. Now, let me go back to the standard window. Assuming you were here in the standard window, if I hit this graph, I only see one line here. So this is actually not going to work out for me. So what I need to do is I need to increase this window. Again, we can hit the zoom key and we can zoom out if we want. Really what we are primarily focused on is just increasing the x's. So if you hit the window key, currently our x is about candles. So I'm going to change my x minimum to 0. I'm going to change my x maximum to, I don't know, let's say 250. Then I'm going to hit zoom and go down to 0. Zoom fit. What this is going to do is going to adjust the window to better fit my graph based on what I wanted from 0 to 250. So now this gives me a 0 to 250 on the x-axis, and it fits it on the y-axis, and I can see the intersection. So second, trace, intersect, hit enter on the first curve, the second curve, and no need to guess. And there we have the intersection point. So x equals 150, y equals 1425. So it says present your answers found in part C with the context of the problem. Well, on the last problem, we were looking for two answers, basically. We were looking how much of each alloy do we need. In this problem, the only thing we were looking for is how many candles do we need to sell. I'm not worried about what the cost or what the revenue is. We do get that number through the Y, but really all we need to know is 150 candles need to be sold. And there we have our answer here for part D. So breaking these down into writing equations and then solving them graphically helps us to then put context to our answers to answer the problem. For all of our word problems, we are going to be able to solve them graphically. The only time you have to solve algebraically is if you're directed to. So let's go ahead and take a look at problem number 8, our final problem here in the notes. It says an airplane flying due south from St. Louis to Baton Rouge, Louisiana, has a steady tailwind to help complete the trip in only 2.5 hours. On the return trip, the same wind slows the flight and it takes 3 hours to get back. If the flight distance between these cities is 912 kilometers, what is the cruising speed of the airplane and how fast is the wind blowing? So there's two things that we're looking for here. Now, this didn't tell us what to assign variables to, so let's make our own variables. One of the things that we're looking for is the speed of the airplane. So I'm going to let that be A because it tells us nothing about the kilometers in this case, kilometers per hour, how fast the airplane is moving. The other thing that we want to find is the speed of the wind. Again, it tells us nothing about the rate of the wind, so I'm going to make that a W. Now, one thing to remember that you have covered before in previous classes is that you find distance by taking your rate or your speed times time. That's how we find distance. So this is how we're going to set up our equations. The first equation is the trip from St. Louis to Louisiana. The distance is 912 kilometers. So 912 equals the rate is the speed that it's traveling. Now, it doesn't tell us how fast the plane is going, but what it tells us is the tailwind is helping complete the trip. So the rate is going to be how fast the airplane moves plus how much the wind is pushing it. The time on that trip is 2.5 hours. So we take distance equals rate times time to come up with this equation. 912 the distance, the rate is A plus W because the wind is helping, times the time, 2.5. Now we need another equation for on the way back. On the way back, the wind slows. So the distance is still the same, going the same amount. But this time the wind is taking away from the airplane, it's slowing it. So A minus W, and then it takes 3 hours. So these are our two separate equations. Now, let's go ahead and distribute here to rewrite these a little bit. So 912, if I distribute 912 equals 2.5A plus 2.5W, and 912 equals 3A plus 3W. So let's actually graph this. So in order to graph this, we need to get either A or W by itself. So let's take the first equation and let's get, let's say A by itself. Let's use A as, let's just use A as our variable we're going to get by itself. So what I would do here is I'd subtract 2.5W from both sides. So I'm going to write this over here, 912 minus 2.5W equals 2.5A. Now I need to divide by 2.5 to get A by itself. So in the calculator, let me clear out of this, clear out of that. 912 divided by 2.5 equals 364.8, and then negative 2.5 divided by 2.5. So that would be 1, so minus, or negative 1, so minus 1W would just be minus W equals A. So I can put this equation into my calculator. Let's use A as W. I probably should have done that from the start, but let's just use A as W. I'll go back here and add this in. And, sorry, let's use A as Y because that's by itself, and X is W. So Y is by itself, so 364.8 minus X. In your calculator, you have to use X and Y. So I probably should have used X and Y, but that's okay. Now let's do the other equation, the same method. Let's take the 912 and let's get A again by itself. So subtract 3W. So 912 minus 3W equals 3A. Divide by 3. So 912 divided by 3. If you need to do it in your calculator, it's okay. 304. I'm not even going to divide 3 by 3 because everybody should know that's 1. Did it on the last one, but I'm not going to do it again. There we go. 304 minus W. So again, we're treating W as X on the calculator. So if I graph this under my normal circumstances on my calculator, I see nothing. So I need to extend my window. So I'm going to take my Y minimum to 0, or my X minimum to 0. I'm going to take my let's leave the Y's alone. Let's take X minimum to 0, which is the rate of the wind. And I don't know how fast the wind blows. Let's make it to 100. Tornado speed. And hit zoom, 0 to fit the graph. We don't have any intersections there. Ooh. Hold on just a second. I think I've made a mistake. Haha, I see my mistake. And hopefully you guys were able to catch this. What I did here, this, when I distributed this 3 to the W, that should have been a negative W here. So this changes things a little bit. This should be a negative W there. So I should be adding 3W here. So that would make this positive and would make this positive. There we go. That makes a bit of a difference. So let's make this 304 plus X. And there we should have the correct graph. Sorry for that mistake. If I knew how to edit it out, I would. But we're going to have to roll with just going back and fixing it. So be careful when you distribute what your signs are. This should have been a negative 3W, making this plus W. So now as I take a look at the graph, I can find second, trace, I can find that intersection. Hit enter on the first curve, enter on the second curve, and there's my intersection. So what this gives me is X, which we said was W, is 30.4, and Y, which we said was A, is 334.4. So let's go back to the context of the problem. So the rate of the airplane, and we do want to make sure we include units here, is 334.4 kilometers per hour. And the rate of the wind, or how fast the wind is blowing, is 30.4 kilometers per hour. And there we have it. So, solving systems of equations. Two linear equations, or a linear equations given two variables. We can use three different methods: graphing, elimination, and substitution. Each have their own purpose and their own kind of shortcuts. Graphing is definitely probably a little bit shorter of work in most cases. And we will graph when we can using word problems. The algebraic methods, substitution and elimination, will be used when we are told to in those certain situations. But you can use all three. If you do it correctly, all three of them should get you the exact same answer in each situation. At this point in time, you guys should be finished with the notes. Make sure you have good notes taken down, because you guys can use that when it comes around time for the quiz. You should be working on your homework, which is going to be found in IXL. Again, to complete, considered complete on the homework, you have to have a SMART score of 80 plus on each section, or a SMART score of 40 plus with at least 15 minutes of practice on each section. Pay attention to Google Classroom for the next Zoom session, where we will be able to go over questions that you have on the notes or questions that you have on the homework in preparation for our assessment. Thank you guys for tuning in, and have a great day.